Hello everyone, and welcome to another episode of Programming in C++. I know it's been a while, so let's get right to it. Today's topic is about APIs. You've probably heard of its definition, but in case you have not, it means Application Programming Interface. It basically is a set of definitions, subroutines, and/or protocols to build software. If you have a good and easy understanding API, it can make programming a lot easier and maybe even faster. APIs are handled differently by different operating systems. For example, in Windows you would probably put an API into a DLL file and in Linux into a .so file, and both are shared libraries respectively to the operating systems. So we will start our own API today and see how we can make use of it. So for that, first we create a new project. And it will be a library project, a C++ library. We choose, shared library, and we call it API. Create in home programming, desktop. Any details we have to look out for? No. Just keep pressing next, next, next. Add to version control, no. Let's build the project for now. Great, so that is it. So let's create a second project at the same time. This will be an application. Let's go check for non-Q3. Yes, a plain C++ application is what we choose. And we call this API test. We press next, 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 finish, and build it. And for that, we have already done the first step to create an API definition and create the class, the project which we make use of to testing the API. So the next step we're going to do, as you can see here, we will copy the linked list we made in our previous examples. So for that we copy the linked list, however we prefer copying the linked list over. So let's see what happens if we add existing directory. We already have those. No, we don't want to add this to API test. We want to add this to API, add existing directory. We press OK. Now let's give it a second. There we go. Linked list is in. Then, so what we do is remove the file. We can delete that file actually permanently. So that is done. We go into Node and we will cut and paste these into the public section for now and see if it builds. Yes, we have no issues building anything. So what we do now, we go into stack, and here you can see template class T include linked list. So what we do, we create a namespace, API. We open a bracket and we close one. Namespace API, and we close, and we do the same for linked lists. We will create a namespace API, open bracket, scroll all the way down, all the way, and we will close the bracket. Done. So what is a namespace? Well, a namespace is basically a definition where you can put code inside so you can remember where you have the access to. So for example, what I did here, I did something forbidden. I used namespace std by using namespace std, and this does not require me then to use cout. If I would remove this, I would have to do std :cout. So this is what we are going to be doing with the API later in our test project. Okay, so now that we have built the API, we will add a library into the API test. This will be an external library. The library file, we select browse and we go to where the library is located, and in this case it's the libapi.so. I press open and check the include path. The include path is different in my case, so I go back, I go to API, and this is where I set the include path to. So I will press next and finish, and that is it. I will run qmake, yes, save all, and then I will build project API test. Okay, so far it worked, and let's see if we can find our include file of linked list. There's linked list, and we have linked list node song stack. Great, so let's include linked list. Let's include also song. At that point, okay, so let's test if the API actually is working. So first I create a song as usual. We call this artist blah, and the title is also blah. Okay, so let's test it out. We created the namespace API, right? And see if we can make use of that in here. API linked list. There we go. Then we have a song pointer, linked list. Let's see if we can build the project. Yeah, it works. So this is already how we make use of the compiled.so file. We created the SO file in here, and then we wrote some code in here to make use of the SO file in the API test class. So let's see if it actually works. Linked list dot add front. Yeah, let's use at front arg, and then see, I'm removing the using namespace std, and now I have to do std : count linked list size and then NL. Let's see what's happening. Build project API test. And what happens if we run the program now? There we go. Hello world linked list size 1. See, that is already how we make use of the API. So let's extend that API now by a different class. And that class will be called string. It's actually a good exercise to create your own set of string operators and string functions. So let's select add new C++ class, and we call it actually just string. And you can see in the path here, it's called API, and I type in string. It doesn't let me do that. So I create a new folder, string, press choose. That's it. And now it creates the new class for us. So it should create us new folders here. There we go, string.h and string.cpp. So what the first thing we do in string.h is we call namespace API, and we end this here. Namespace API. So that works. Good. Okay, now that we have the class created, let's build it, see if it works. I build a lot. String does not name a type. That is okay. That is to be expected right now at this point. So since we made this namespace API, we do API double colon, and now if we build, let's make this our active project for now. Build project API. There we go. Okay, so let's go into string. So here we create an empty string object. So what function do we need in a string, for example? So first we do another constructor where we take an input, create a string which contains the sequence of input, and we create another string which contains the sequence of input with at most number of characters. So string const char input, and we do size t num. So create a string object which contains a sequence of input with at most num characters. So in this function, when we type in hello world, but the number is of size 5, then we cannot have more than hello standing in there. I think that makes sense. So we create a virtual destructor, virtual string. So of course we want to get the length of the string, right? So we can do that in two ways. We can have a static int length of const char string. This returns us the length of any string. Returns length of any string. And then we can have the int length, which returns the length of the current string. So length of current string. We can have print string, print the current string, right? We can also do operator overloading for the string, but this will be attacked on later. We will do operator overloading in another session. So we can do a copy a string. We can static void string copy. We can char destination, and we do have the source. So the source is a const because we don't want to change the source, but the destination we can change because we have to copy the source into the destination. Then we have static void string length copy, which is another destination and a source and size t length. So copy the source into the destination with a maximum length of length. So what other functions are useful in a string class? We can reverse a string, for example. Reverse a string, and those are base functions we have. So we have a private section, we have in string length. Let's see if we can make use of that, and we have a char input string. That is it for the header file for now. So let's go to the class of the C++ file, and we do this dot string length equals 0. We initialize that, and we go to the second constructor actually at that point, because this is all we can do. We do this one, and here what we do, this input string is now we have to allocate some memory for the input. So for that we're actually using a C function called malloc. So since we're using a newer C++ standard, we have to cast it with a static cast as a char pointer, because this is a char pointer and input string is a char pointer, right? We need to be consistent with that. We call malloc. Then we're using our own length function for that, so we cannot compile the code just yet. And then we multiply the input by size of char. This is to allocate the exact amount of memory we need for the input of length. And then we actually make use of our own function again called string copy, and this input string, which is the destination and input. So first we allocate memory for input string, because malloc returns a void, but it returns the amount of memory which we cast to a char pointer, because input string is a char pointer, and we copy input into input string. So we have the length of size input multiplied by the size of a char. Okay. So we have to go back to the string.h for a bit, because we need the malloc function available. So for that we add a few C headers, include stdio, include stdlib, just in case we make use of some of the functions, we make use of IOStream. Okay, we'll go back here. So we still can't build anything because we haven't built string copy and length yet. They are in the header file, but we haven't defined those yet, what they do. So similar for the next constructor, the third constructor, string, and we use that one. So it's the same thing again. This time it's a bit different though. So this input string equals static cast char pointer and then malloc. Now we use num because we're having a maximum length times size of char, and then we do a string length copy this input string input and num. This is for that constructor, and we have a virtual constructor, we can't forget about that. Right, so, and there we are going to be using free this dot input string. So because if you allocate memory, you have to free up the memory, and I know those are C functions, but we are allowed to use those in C++ for memory allocation. Let's go to the length function first, okay? So what we do is, it was an integer, right? So int API string length. We have a string as an input. And what do we do here? So we have an integer of length equals 0, and then we have int I equals 0 because we have to iterate through the string now. So we do for I equals 0, I smaller string, the input string I, then I plus plus. So we are iterating through the string itself, and then we're increasing the length variable by 1 every time we hit length. And when we're done, we simply return length. So if the string is a string of 5, it counts from 0, 1, 2, 3, 4, which is 5 in length. So this is the length function. Let's do the string copy, because we are using that up here, and then we need to do a string length copy. So we have 2 more functions ahead before we actually can start making use of the string class. So the string copy was a void API string copy. Let's the program fill that out for us. And here we are doing some operations now. We are doing a while loop, and we dereference source in that case. While source is not equal to a null termination, right? So while dereference source is not equal to null termination, we dereference destination equals the dereference of source. Then we do destination plus plus and source plus plus. So why are we doing a dereference? So with a dereference, we are basically at the position, at the current position of source, for example. So let's say we start at position 0 with a dereference, and that position 0 is not a null termination. Then we assign position 0 of destination, position 0 of source into position destination, whatever that is. And then we increment by 1 next time we meet destination or source. So that's basically a short definition of a dereferencing pointer. So next, if we do void API string length copy, we are going to be actually different. We are not going to dereference anything. We are doing I equals 0, and then we do while I smaller length. So let's say the string is 5. We start at 0 and we go to 5. We will do destination I equals source I, and then we increment I by 1. And that is it for string length copy. Let's add the reverse function before we do anything. I think that's the last function as well. And then we are going to be compiling the API class, and we are going to be using it in the API test project. So void API string reverse. So we have char reverse equals input string, because we are having access to our in-class parameters, right? So for and I equals length of reverse -1. Then we have I greater equals 0. Then I minus minus. So what we do is we start at the end of the string, and then we're checking if we reached 0 or greater. So, and all we do, really simple, we do reverse I. So we're using stdcot, that's what we included IOStream for. Let's build the project and see if it actually builds. Nope, it does not. So let's see what the issues are. Okay, I found the error. It's const char, not just const source. It is const char source. Same with here, it's const char source. Okay, so now let's build again. Build works fine. Okay, let's go to main CPP if we can make use of the API string. So what we do, we include string h. Okay, let's remove that. And then what we do is we create char, some char, and then we do char new char equals, let's create some memory, char pointer size of char, and new char equals blarg. What we do is we use the string copy function now to copy some char, new char into some char. Let's see what's happening. String copy some char, new char, some char. And you see me doing a plus for doing the text. That is because I've programmed in Java before. Let's do that. Let's set that as an active project and let's run it. Okay, I get no output, which is what we intended to do, because we did not initialize some char. So if you actually do initialize some char, like let's say with this, right, then it should work. Let's do another test. Run, and there we go, blarg. So it copied over successfully. So let's test the string length copy function. So we have some char, new char. We have new char, it's me now. And we have new char to some char, but we limit the length to 3. Let's limit the length to 3. And string length copy, of course, not string copy. Let's run the whole thing again. There we go, some char blah. Okay, so now that we tested some functionality of the class, let's test the string itself. Okay, so let's say creating the string, new string equals new API string. And this theoretically, if I print the string now, new string, print string, should not work. Print string looks really simple. This is print string, we just print the input string and that's it. So if I compile and run this, this should not work. So how I can prove that? Let's create a second string, new string 2 equals new API string. This is my input string. And if I print new string 2, print string, right? So something is crashing there, right? So we can theoretically remove this constructor, or we have to rewrite a couple things on that. So let's remove this for now. We have new string 2 and we have API string new string 3 equals new API string. This is a string with limited input, and we limit the input to 15 in this case. We already have seen that new string 2 printed. Let's print new string 3, print string. Let's see what the output is. This is my input string. This is a string, so must be limited at 15 here with limited input. So that is working. So let's look at our reverse function. We just type in the string and we reverse. So new string, actually let's make it new string 2 different. We could do auto, so you don't see that it's reversed anyway. Little joke aside. String new string to reverse, and then we do new string. Apparently I can't type. New string to print string. There we go. Let's see what we get as output. String, string, string. Oh, the function is printing the string itself. Fair enough. Let's do that again. There you go. So this is a simple definition of creating your own API plus a really simplistic string class which can basically do next to nothing. Thank you for watching the video. I will see that I can upload some more next time with different ideas. Thank you for watching. Have a nice day.